Welcome again to the continuation on the position vectors that I started with you in the first video. In the first video, we started learning about position vectors and we've done a detailed explanation on it, and also we've solved an example on it as well in the first video, and I hope you understood it and you enjoyed the lesson as well. So in this video, I want us to solve another example so that you get a perfect understanding of it. So this is example 2, as you can see from the board. So it means we've already done example 1 in the first video, and I will encourage you to do well to watch the first video, because the first video lays the foundation, the basic knowledge and understanding that you need about the position vectors. I've done all those explanations in the first video. Okay, so please do all to watch the first video so that you can get the necessary understanding to be able to handle this one as well. And also please don't forget to like the videos and also share them after watching. And if you are watching for the first time, please do all to follow the page and also subscribe to my YouTube channel as well. Let's go ahead and take a look at the example 2 that I have on the board. Let's read it together. Okay, so example 2 says that if the point P is given to be -1, 3 and the point Q is given to be 2, 5, find I, the vector PQ, and II, the vector QP. Okay, so I'm going to read it one more time before we proceed and solve it together. Again, it says that if the point P is given to be -1, 3 and the point Q is given to be 2, 5, find I, the vector PQ, and II, the vector QP. Okay, we are being asked to find the vector PQ and also the vector QP. Okay, so first of all, let's write down the information that the question gave us. Okay, we have been given the points P and Q. Okay, so let's write it down and change those points to position vectors first. I've taught you this and I've explained it a lot in the first video, so we are just going to apply the knowledge to solve this one as well. Okay, so let me write down my solution and let's do it together. Okay, so the point P is given to be -1, 3, which we can write as a position vector. Okay, a position vector simply means that a vector which starts from the origin. So given any point, you can express it as a position vector. Okay, so writing this point P as a position vector, so this point P in position vector will imply that my OP will be equal to -1, 3. Okay, and I hope you understand and you agree with me. I've explained this a lot in the first video. Okay, so OP meaning that we are starting from the origin. Okay, so OP equals to -1, 3. Then also we have the point Q given to be 2, 5. Okay, so this point Q, I'm going to write it as a position vector. So this one will imply that I'll have my OQ vector. OQ will be equal to 2, 5. Okay, so that's the first step. Okay, expressing the given point as a position vector. Okay, now the I part of the question says that we should find the vector PQ. Okay, so let's start with the I. So the I, we have to find the vector PQ. Okay, and for us to find the vector PQ, I've explained it to you from the first video that it's always the position vector of the last letter minus the position vector of the first letter. Okay, so having PQ here, the last letter is Q. So the position vector of the Q is going to be OQ. Okay, so it's going to be OQ minus the position vector of the first letter. The first letter is P, so it's going to be OP. I hope you understand and you agree with me up to this point. So from here, we just need to input our values so that we can solve for the vector PQ. So my PQ will be equal to, I have OQ given to be 2, 5, so I'll input my value 2, 5, and minus my OP given to be negative 1, 3. Okay, so this is how you go about it. Now let's simplify and get our final answer. So we are just applying the addition and subtraction of vectors that we learned, okay, to handle this part. Okay, so let's simplify further. So 2 minus 1 is going to give me positive 3, because when two negative meet like that, it becomes positive. Okay, then I have 5 minus 3 is going to give me 2. So this is my final answer for finding the vector PQ, and I hope the explanation was clear enough and you understood it as well. So now let's go ahead and handle the II part as well. The II part is saying that we should find the vector QP. Now if you observe carefully, you can see that QP is just the inverse of PQ, and I've taught you inverse of a vector in the first video. Okay, I've explained all these things in the first video. That's why I keep on encouraging you to watch the first video. So the QP that you have to find, which is the II, is just the inverse of the PQ. Okay, so look at it. QP is just the inverse of PQ. How do we do? I explained to you that the inverse of any vector is simply the opposite of that vector. So if I have AB, the inverse of AB is going to be BA. And for you to get the BA, what you do is that you just need to negate the AB, and that will give you the BA. So in that same understanding, we have PQ here. We have PQ to be 3, 2. And the II is asking us to find the QP, which means that the QP is the inverse of the PQ. How do we get the inverse? We just need to negate the PQ and then to give us the inverse, which is the QP. Okay, so let me go ahead and do that. So the II, we have to find QP, which will be equal to the negation of the PQ. Okay, so when I negate the vector PQ, then it will give me QP. Okay, so let's continue. So my QP will be equal to, bring your negative sign, then you put the value of the PQ there. The PQ we solve for it, which is 3, 2. Okay, so you bring your 3, 2. Then now you go ahead and simplify. So your QP will be equal to, the negative will affect the number at the top here and also affect the number down here. Okay, so I'm going to get minus 3 minus 2. Okay, that becomes my final answer. Okay, so I hope the explanation is clear enough up to this point. Or you can choose to go by this approach to find the QP. You get the same answer. Or you can say that to get my QP, the vector QP, it will be equal to, as we said, it's always the position vector of the last letter minus the position vector of the first letter. So QP will be equal to the position vector of the last letter, which is the P, is going to be OP minus the position vector of the first letter, which is the Q, is going to be OQ. Okay, then you input your values and you solve. You still get the same answer as this. Okay, let's try it and see. Okay, so my QP, vector QP will be equal to my OP. My OP is minus 1, 3. So I'll put it there, minus 1, 3, minus my OQ. My OQ is 2, 5. So 2, 5. So when you simplify this, you get the same thing. Okay, so let's check and see. Minus 1 minus 2, it gives minus 3. So you can see we have minus 3 here. And 3 minus 5, it gives minus 2. So when you simplify this, you get the same answer. Okay, I don't have enough space there, that's why I've left it. But you can see that when we do the subtraction, we are getting the same thing. So either you go by this approach or this approach, you get the same answer. Okay, and the reason why I like to use the first approach is because I want you to get the understanding of the inverse of a vector. Okay, and that is very short and simple. That notwithstanding, this approach is equally easy as well. So any way that you are okay with it, you use it. So I hope you enjoyed the lesson and you understood it as well. Please don't forget to like the video and also share them after watching. And if you are watching for the first time, please follow the page for me, okay, so that any new video that I upload, you can see it. And also subscribe to my YouTube channel as well. I'll see you again in another video whilst we solve other examples on this. Bye bye.